Hello everyone, the topic that we will be covering today is linked list ADT. Linked list ADT is basically a type of data structures. So before going into further detail, we must know what a data structure is and what do we mean by data structure. So data structures are the container of the data, that is, it save and contain the data during the runtime and make it available to be manipulated or various operations to be performed on it. One of the most commonly used data structures that we commonly see is an array, which is basically the collection of the elements of similar type uh, located right next to each other. There is contiguous memory location, that is one you can all the memory chunks are located all together very next to each other. So the advantage of this type of data structure is you can randomly access any element at any particular index. That is, if you want to go to third index, just type the address or insert the value of index in a particular array and you will get to that particular index. However, array is not suitable because it has the fixed size. It is a static data member, that is, if you want to add any a new memory or free the existing free memory allocated memory, you cannot do so in the array list, which means that you have very ineffective memory utilization. It cannot handle the unprecedented changes. That's why we need dynamic data structure, which is flexible in the sense that it can allocate memory, it can free memory, it has a focus on memory customization, and it do all the memory at the runtime. That is, there is no wastage of memory. If there is the requirement that you want to allocate a new memory block, you can do so. If you no longer require that memory, you can also eliminate or free that memory from the you can say existing list or whatever. So the most commonly used data structure, dynamic data structure, is linked list. The one we will covering in this lecture. Linked list is basically a linear collection of data elements where each and every element points towards the next element of the list. It has non-contiguous memory allocation, which means that you can allocate memory at any time wherever the memory is available in your memory block or hard disk. It will be allocated to your program, to the list that you that has requested that, and whenever memory is no longer required, it will easily be freed from that. So when we talk about the structure of the list, it basically comprises of elements, that is, in programmatically term or in programming point of view, we call that nodes. List comprises of certain nodes or series of nodes that are linked together by a pointer. So when we talk about a node, it has two parts. One is data part, another one is the pointer part. In data part, we can save all the data. You can see I've pointed the mouse over here. Here you can add any data, any type of data, and the pointer here will point towards the next node or the next element of the list, whereas this box points towards the linked list, and A, B and C are different nodes that are linked together via next pointer, and the last pointer here points towards the node, and the first node is pointed by the linked list head. Here one thing to remember is you cannot access any element randomly, so you have to go iteratively or in a sequential manner from head to the last node. So first you jump to A, then B, then C. You cannot skip any particular node to move towards the next node. The first node is pointed with the head pointer, and this head is also of type node, and it always points towards the first element of the starting element of the node A. You can see it from here that there are three different nodes. Each node points towards the next node, and each node has its particular, you can say, item and the next pointer. A few applications of linked lists include stack, queues, binary trees, hash table graph. These are the data structures as well that are built upon linked lists. They can be built upon array, but again the same problem will be faced, that it cannot handle the unprecedented changes. In real life, you can see whenever we try to solve the polynomial expression, we add them, multiply them, whatever we want to do, that we need the help of the linked list, so that runtime elements of you can say each and everything could be inserted and manipulated accordingly. Similarly, in real life, you can see the example of image viewers and music player that basically link every previous element with the next element in order to play the next video or open the next, you can say, image. And there are numerous other examples you can see in real life. There are different type of linked list: singly, doubly, circular. The one we are discussing in this tutorial is singly linked list, where you can see from here we have got a node class, and each node has the data member, which is I have used integer type of single data. You can add any data members or variables attributes here. The node's direct next represent to the next pointer that would be pointing towards the next element of the list. So considering the linked list class, we have got node pointer head here. It points towards the very first element of the node, or the linked list, first element of the linked list basically, which is a node itself. That's why its type is a node, and it has got various other functions that I'll be explaining next. And list is you can say the first two functions, which are constructor and destructor. These are by default functions or functionalities of the class that we can override, or we can add functionalities as per our own need and requirement of the, you can say, program or the task. So the list function that I have included here includes is empty, that shows basically whether a linked list is empty or not. To insert a node at particular index, we use the function insert node. To find, we use find. To delete node. Display parents list, and search node, basically search for any particular node in a list. And you can add any number of, you can say, functions here that perform functionalities as per your need. Here you can see that I only have taken one node, data type, one data member, which is in data. So there is only one function. You can see it from here. I have only considered one data member, int data. Therefore my whole function revolves around the single data member, that is single int type of data member in data. And you can customize them according to your need or requirement of the program. That's it for today's tutorial. If you like the video, please don't forget to subscribe the channel and like the video. In case of any query, feel free to drop a comment. I'll get back to you as soon as possible. Thank you for watching.